Hello, student. Last time in last lecture we already discussed what is the data, what is the type of data, then what is the data structure, what is the type of data structures, and basic things related to detailed description of data structures types. Now today we discuss with algorithm. What is algorithm? Okay. Any computer program uh, which accepts some input data, performs some operations on that data, and gives some useful output or gives some meaningful information to the user. So, an algorithm is related to the manipulation of data or the operation which performed by the computer program. Okay, so it is a method that can be used by the computer for the solution of the problem. So definition of algorithm, we can say that it is a finite set of instructions that is followed or completed to complete a particular task. Okay, in short, algorithm is nothing but a finite set of instructions that is followed or completed to complete a particular task. Okay, here is some examples of algorithm to calculate the area of circle. Okay, then we write the algorithm for calculating the area of circle. In that, the first step is a start. Every algorithm's first step is a start. Then second step in calculating the area of circle is accept the radius. Okay, as we all know how to calculate the area of circle, there is a formula which is a pi r square. Pi means it is a constant value, then r means radius. Okay, so first accept the input which is a radius. So second step is a accept radius. Third step is calculate the area. Then as we know formula of circle, area of circle is pi r square. So for calculating the area of circle, there is a pi into radius. Okay. So calculate the area. Then next step is display the area. And last step is a stop. So this is the algorithm to calculate the area of circle. Now, what is the main characteristics or the all algorithm which must satisfy some criteria, and this criteria is known as the characteristics of an algorithm. The first criteria is a finiteness, or we can say that the first characteristics of algorithm is a finiteness. What is mean by finiteness? If we trace the steps of an algorithm, the algorithm must terminate after finite number of steps. Okay, इसका मतलब क्या है कि finiteness means every algorithm must contain finite number of instructions. Okay, this is the first characteristics of algorithm. Now the second characteristics of algorithm is a definiteness. What is mean by definiteness? Each step of algorithm must be precisely defined. That is, each instructions of algorithm must be clear and unambiguous. Okay. Each and every instruction in algorithm must be clear and unambiguous. So this criteria or this condition is known as a definiteness. Okay. Now the next step is a effectiveness. Effectiveness means each instruction must be sufficiently basic that it can be done exactly and in finite time. A person using only paper and pencil means इफेक्टिवनेस. इसका एग्जाम्पल क्या है? अगर हम दो नंबर्स ऐड करते हैं, ऐड नंबर 1 टू नंबर 2 is an effective operation if number 1 and number 2 are integers. But what happen if number 1 is a integer and number 2 is a string? Then this is not effective instruction. So this effectiveness is the another characteristics of an algorithm. Okay, now next characteristics is a input. And every algorithm takes 0 or more inputs. Okay, means हर एक algorithm को 0 or more inputs हो सकते हैं. And the last characteristics is a output, and every algorithm generates one or more outputs. Okay, so these 5 characteristics defines the algorithms. Okay, every algorithm must satisfy these 5 conditions. Again, I repeat this: finiteness, definiteness, third one is the effectiveness, fourth one is the input, and last one is the output. Okay, so this is the characteristics of algorithm. Next point with which we discuss is there is some criteria on which an algorithm can be evaluated. There is some criteria. On basis on that criteria, algorithms can be evaluated. The first criteria is that does it performs the desired task. Means अगर algorithm हम define करते हैं तो वो algorithm specific task perform करता है या नहीं. Means does it performs the desired task. Then second one is does it work correctly according to the original specification of the task. Means जो भी algorithm हमने define किया है वो original जो उसका specification है उसके accordingly वो work होता है या नहीं. Third one is does it contains the documentation describing how it works. Okay. And the fourth condition is are procedures created in such a way that they perform logical subfunctions. And last one is a code readable. So whenever we define or we write the algorithm, that algorithm must satisfy these 5 criteria. Okay, and these criteria are important, but they are a qualitative criteria. Okay, these criteria satisfy or qualify the algorithms. Okay, but it is not always possible to measure this criteria. The performance of algorithm is evaluated or is calculated basis on some another criteria, and this criteria is known as a space complexity and time complexity. Then what is mean by the space complexity? Space complexity means it deals with the storage requirements. Okay, and the time complexity deals with the computing time. Okay, so next point we discuss in detail with the space complexity. The definition of space complexity of an every algorithm or program is the amount of memory a program needs when it executes. Space complexity is defined as the amount of memory when a particular program is executed, and that program needed some memory. That requirement or that amount of memory allocated by that particular program is known as the space complexity of that program or of that algorithm. Okay, clear. Now the components of the space complexity. The space complexity needed by an algorithm is the sum of the following 2 components. The first part is a fixed part and the second part is a variable part. Then what is mean by the fixed part and what is mean by the variable part? This part, fixed part means this part is independent of the characteristics of the inputs and the outputs. It includes means जो भी fixed part memory है और जो भी fixed part space complexity है उसमें जो भी हम simple variables, component variables और constant declare करते हैं उनको जो भी memory allocate होती है उसको हम fixed part space complexity बोल सकते हैं. Okay, and the second part is a variable part space complexity, and this variable part complexity is based on the size of that particular problem or the size available for that particular problem is known as the variable part. For example, uh, suppose the space complex for example, here we write a function float area Here we define a function area which accept one parameter r as a type of float, and this function returns type is a again float, and here we calculate the area of circle. Here we write the return 3.14. 3.14 is the constant value of pi, and r into r. R into r means radius. Okay, so this function calculate the area of circle and returns the area of circle. Okay, so in this example, the space needed is independent of the input and the output characteristics. Here, we not consider the area or memory required for R. Here, we just calculate the area of circle and return this area of circle. So the space requirement of this function is a SP. SP means space complexity, and the C means constant 1. So here the space complexity is a SP is equal to 0 and C is equal to 1. Here space complexity for an algorithm is written as C is equal SP. SP indicates the space complexity, and the SP is equal to C plus SP. C means what? C is a constant and is a fixed part, and SP means a variable part. Means ये जो हमने two parts देखे हैं space complexity के fixed part and the variable part. By adding these two parts, we get the space complexity. Okay, or in this example we see here 3.40 is a constant value, means fixed part memory requirement, and the variable part in this example we need not depend on the input and output. Okay, we only depends on this calculation. So here space complexity is a SP plus C is equal to 1. So space complexity for this function is a 1. Okay, similarly here is another example of space, how to calculate the space complexity. Here integer, we write another function array of sum. Okay, in that array of sum we take two variables or two parameters of type integer. One is a one dimensional array and second is a variable. In this function we calculate the sum of elements which contained in this array, and we calculate the sum and return this sum to the calling procedure. Okay, so in this example there is a this algorithm is depends on n. What is mean by n? N is the number of elements in this particular array. If we require fixed space for three variables I, S and N, then the variable amount of memory is for n value is the array. So constant is 3 and a variable part is n. We don't know how many numbers are there in array. So variable part is depend on n and the constant part is I, n and sum. Okay, so constant is 3 and variable part is n. So by adding these two variables, we get the space complexity. Clear? Here is another example. Here we write the recursive function, and in recursive function, we call the one variable. This recursive function accept the one variable of fixed memory. However, there is an additional memory required for recursion, which depends on the value of n. If n is 0, there is no additional memory requirement. If n is greater than 0, the recursion stack space includes the space of our current value. Okay, so we can calculate this space complexity for this function is constant requirement is 1 and variable part is 2 into n. So total space complexity is equal to C plus SP, means 1 plus 2n. Okay, so this is the space complexity. Then what is the time complexity? Time complexity of program is defined as the amount of time the program requires to execute. Okay. However, it is difficult to calculate the exact running time, but also we can sorry, calculate the exact running time, but the exact running time depends on the underlying hardware and software. Instead of calculating exact running time, we rough estimate can be made of execution time of particular program. Okay, so total number of active portion is defined as a frequency count. Means टाइम कॉम्प्लेक्सिटी में जो भी एक्टिव ऑपरेशंस है उनको एग्जीक्यूट करने में कितना टाइम लगता है वो तो कैलकुलेट कर सकते हैं, और जो टोटल नंबर ऑफ एक्टिव ऑपरेशंस है उनको हम उनका जो काउंट करेंगे उसको हम फ्रीक्वेंसी काउंट बोलते हैं, फ्रीक्वेंसी काउंट. ओके, सो look at these examples. Here is an example of A is equal to A plus B. Okay. These statements, A is equal to A plus B, this statement executes only once. Okay. Means execution of this statement done only once. So frequency count of this statement is 1. Take another example. Here is a for loop for I is equal to n, I is greater than 0, and greater than 0, and I is equal to I divided by 2. And here in this loop we write a statement A is equal to A plus B. So in this example A is equal to A plus B, this statement executes the log to n times. So frequency count for this A plus B is equal, frequency count is log to n. Okay. Now take another example. Here we write a for loop. In this for loop, I is equal to 1, I is less than or equal to n, I plus plus, and we write A is equal to A plus B. So this A plus B statement execute n number of times. Mean जितनी बार ये loop for loop execute होगा उतनी बार ये A is equal to A plus B statement execute होगा. So the total number of frequency counts of this statement is n. Okay, now this is the another example. Here is a 2 for loops which execute n number of times. So A is equal to A plus B statement execute n into n times. So frequency count for this statement is n square. Okay, so for calculating the time complexity, we calculate or we make the rough estimate of exact एग्जैक्ट तो नहीं कर सकते लेकिन रफ एस्टिमेट बना सकते हैं टाइम कॉम्प्लेक्सिटी. तो ये जो टाइम कॉम्प्लेक्सिटी है वो फ्रीक्वेंसी काउंट करता है, और फ्रीक्वेंसी काउंट हम किसे बोलते हैं, जो भी एक्टिव स्टेटमेंट है, जो एक्टिव स्टेटमेंट कितनी बार एग्जीक्यूट होते हैं उससे हम ये फ्रीक्वेंसी काउंट कैलकुलेट कर सकते हैं. ओके, सो in some cases the frequency count may be polynomial. Means यहाँ पे एक एग्जांपल है, इसमें एक पॉलिनोमियल फंक्शन दिया है n रेस्ट टू 4 प्लस 2 रेस्ट टू 2 इन sorry 20 into n raised to 3 plus n plus 4. Then the term with the highest order of magnitude means यहाँ पे इस polynomial में higher magnitude किसका है, n raised to 4. So the highest magnitude जो भी है उससे उसको हम उस polynomial का frequency count बोल सकते हैं. तो इस example में n raised to 4 is a frequency count of this polynomial. Okay, so this is the time complexity and this is the space complexity. Now the next part is a best case, average case and the worst case. Okay, an algorithm must be analyzed means जो भी हम algorithm लिखते हैं उसको हम analyze 3 टाइप से कर सकते हैं. उस टाइप वो 3 टाइप में से एक टाइप जो है वो है बेस्ट केस, second one is a worst case, and the third one is a average case. Okay, so what is mean by the best case? The term best case is used to analyze an algorithm under optimal conditions. Okay, the best case performance is the minimum number of steps that can be executed for the given input values. ओके, सो उसको हम बेस्ट केस बोलते हैं. फॉर एग्जाम्पल, अगर हमने एक अल्गोरिदम लिखा है और उस अल्गोरिदम ने हमने मिनिमम स्टेप्स लिखे हैं, ओके, फॉर प्रोसेसिंग सम आउटपुट basis on some input, we write minimum number of steps. So this algorithm, we can say that it is a best case algorithm. Okay, for example, the best case for the linear search algorithm occurs when the element, आता linear search क्या होता है कि हम sequentially एक एक element, जो भी element हमको search करना है number of एलिमेंट्स में से, तो हम हर एक एलिमेंट को जो नंबर ढूंढना है उसके साथ कंपेयर कर सकते हैं. ओके, अगर हमें फर्स्ट एलिमेंट में ही जो सर्च करना एलिमेंट मिल जाता है तो उसको हम बेस्ट केस बोल सकते हैं एल्गोरिदम का. ओके, सो दिस इज द बेस्ट केस. देन व्हाट इज द वर्स्ट केस? द वर्स्ट केस मींस द maximum number of steps then can be executed for the given parameters. वर्स्ट केस मीन्स क्या है कि अगर हमें कुछ हमने एल्गोरिदम लिखा है और उसको कुछ हम इनपुट दे रहे हैं, इनपुट पास कर रहे हैं, और हमें जो रिक्वायर्ड आउटपुट है वो हमें n नंबर ऑफ मीन्स मैक्सिमम नंबर ऑफ स्टेप्स परफॉर्म करने के बाद अगर जब मिलता है तो उसे हम वर्स्ट केस बोलते हैं. ओके, and the average case is a running time assumes that all input of a given equally likely means 50-50. The average case step count is the average number of steps means अगर n नंबर है और बीच में ही हमें n डिवाइडेड बाय 2 में भी 2 स्टेप्स परफॉर्म करने के बाद ही हमें रिजल्ट मिलता है तो उसे हम एवरेज केस बोलते हैं. So algorithm must be analyzed based on these three conditions. First is a best case. बेस्ट algorithm हमें किसे बोलते हैं? जिसमें मिनिमम नंबर ऑफ स्टेप्स कैलकुलेट होते हैं. वर्स्ट किसे बोलते हैं? जिसमें मैक्सिमम नंबर ऑफ स्टेप्स परफॉर्म करने के बाद हमें जो रिक्वायर्ड आउटपुट मिलता है उसे हम वर्स्ट केस बोलते हैं. और एवरेज किसे बोलते हैं? जो हमें इन बिटवीन मीन्स 50% काम करने के बाद हमें जब भी आउटपुट मिलता है तो हम उसको एवरेज केस बोल सकते हैं. तो on basis of these three cases, the algorithm must be analyzed. Now, the next part is a symptomatic notations. After calculating, means after calculating the space complexity and time complexity, means time means हम frequency count भी बोल सकते हैं. So after calculating the frequency count of program f into n, okay, the time complexity is expressed by using this symptomatic notation. Like there is a three types of notations: big O notation, omega notations, and theta notation. Okay, means best case, worst case, and the average case notations cases डिनोट करने के लिए भी हम बोल सकते कि ये जो नोटेशंस है ये यूज करते. सो फर्स्ट नोटेशन जो है ओ नोटेशन, उसको हम बिग ओ नोटेशन बोल सकते हैं. दिस नोटेशन इज यूज टू डिनोट द अपर बाउंड्स. ओके, मीन्स जो भी वर्स्ट केस बिहेवियर है उसको एक्सप्रेस करने के लिए, डिनोट करने के लिए हम दिस बिग ओ नोटेशन यूज कर सकते हैं. देन ओमेगा नोटेशन. ओमेगा नोटेशन जो है उसका सिंबल देखो यहाँ पे कैसे लिखा है. दिस नोटेशन इज अ लोअर बाउंड्स मीन्स बेस्ट केस बिहेवियर. किसी भी अल्गोरिदम का जो बेस्ट केस बिहेवियर है वो डिनोट करने के लिए ये ओमेगा नोटेशन यूज करते हैं. और जो थीटा नोटेशन है, दिस नोटेशन डिनोट्स बोथ means average case, upper and lower bounds of function, and return as t raised to n is equal to theta g into n. So this is the symptomatic notation which is used to indicate the worst case, best case, and the upper and lower bounds of the frequency count. These three notations are used: big O notations, omega notations, and theta notations. Okay, clear? So this is the algorithm concept, how to calculate the space complexity, time complexity, and to analyze the algorithm on some criteria. These cases are best case, worst case, and average case, and the notations. Okay. So now the next part in this uh, chapter is linear data structure. Linear data structure. In linear data structure, the first data structure we used is a array. Then what is mean by array? Array is the one of the most and important and widely used data structure. This type of means this array data structure is a inbuilt data structure. इनबिल्ट मीन्स जो पहले से क्रिएट किया है, जिसको खाली हम यूज करते हैं, उसको हम इनबिल्ट बोलते हैं. ओके, सो ऑल एलिमेंट्स इन दिस एरे और इन दिस लीनियर डेटा स्ट्रक्चर्स, all elements are in stored in sequentially, means one after the another or in order, and its elements are stored in consecutive memory locations. For example, suppose we denote or we define array int n into 10. So this indicates there is a array whose name is n, which stores the 10 elements, and these 10 elements is stored in memory consecutively, means one after the another's. Okay, consecutive blocks means वो एलिमेंट स्टोर होंगे मेमोरी में. ओके, सो एप्लीकेशन एरियाज ऑफ एरेज. एरे जो है वो कहाँ पे यूज होता है, मीन्स द इम्पोर्टेंट डेटा स्ट्रक्चर विच इज एरे, एंड द एप्लीकेशन ऑफ एरे इज, फर्स्ट एप्लीकेशन इज अ सर्चिंग. सर्चिंग करने में हम एरे यूज करते हैं, सॉर्टिंग में हम एरे यूज करते हैं, पॉलिनोमियल रिप्रेजेंट करने के लिए भी हम एरे यूज करते हैं, स्पार्स मैट्रिक्स रिप्रेजेंट करने के लिए भी हम एरे यूज करते हैं, और स्टैटिक इम्प्लीमेंटेशन, जो भी हम नेक्स्ट डेटा टाइप देखने वाले हैं डेटा स्ट्रक्चर्स के, लाइक स्टैक, क्यू, ट्री, ग्राफ, all that data structure, static implementation of this data structure is implemented by using array. Okay, so this is the application of array. Now sorting. Sorting means what? Sorting is a process. That process is arrange or order the elements in ascending or descending orders. Sorting एक टेक्निक है जिससे हम जो भी एलिमेंट्स है उसको हम ऑर्डर में मैनेज कर सकते हैं, बाय असेंडिंग ऑर्डर और बाय डिसेंडिंग ऑर्डर. ओके, सॉर्टिंग टर्मिनोलॉजीज और सॉर्टिंग डेफिनेशन देखेंगे हम यहाँ पे. इंटरनल सॉर्टिंग क्या होता है, एक्सटर्नल सॉर्टिंग क्या है, स्टेबल सॉर्टिंग क्या है, और इन प्लेस सॉर्टिंग क्या है. द फर्स्ट वन इज अ इंटरनल सॉर्टिंग. Sorting data is done on data which is stored in main memory. जो भी डेटा मेन मेमोरी में स्टोर्ड है उसको अगर हम सॉर्ट करते हैं तो उसको हम इंटरनल सॉर्टिंग बोलते हैं. ओके, देन व्हाट इज एक्सटर्नल सॉर्टिंग? Sorting is done on data stored in auxiliary storage device. Auxiliary means जो भी secondary storage है, फॉर एग्जाम्पल हार्ड डिस्क है, टैब ड्राइव है, CD ड्राइव है, उस पर जो भी डेटा स्टोर है उसको अगर हम सॉर्ट करते हैं तो उसको हम एक्सटर्नल सॉर्टिंग बोलते हैं. ओके, देन इन प्लेस सॉर्टिंग. In place sorting is said to be in place if it is not used in additional memory for sorting. Okay, so this is the sorting terminologies. Then next sort is a sorting technique. में sorting जो है वो है bubble sort. This is the simplest and the most popular sorting method or technique to sort n elements. अगर हमें कुछ elements है उसको sort करना है तो उसके लिए अगर हम bubble sort use करते तो this bubble sort method is the simplest and most popular method for sorting. Take one example to see the working of bubble sort. Here is number of elements 25, 37, 12, 48, 57 and 33. These are the elements which is uh, listed here. Okay, now we want to sort this element by using bubble sort. So here we see the working of bubble sort. First pass means first we write all the elements 25, 37, 12, 48, 57, 33 in first pass. In first time जो भी फर्स्ट एलिमेंट है, वो जो फर्स्ट एलिमेंट है वो जो सेकंड एलिमेंट है उसके साथ कंपेयर होगा. अगर फर्स्ट एलिमेंट इज ग्रेटर देन सेकंड एलिमेंट है तो वो दोनों के बीच में स्वैपिंग होगा. लेकिन यहाँ पे 25 is already less than 37, so there is a no need to swapping. Okay, in first pass, next turn, 37 is compared with 12. Okay, whether there is a change? Yes, 37 is greater than 12, so swap these two numbers. So 37 की जगह 12 जाएगा और 12 की जगह कौन आएगा? 37 आएगा. Okay, in first pass, compare this third element which is a 37. Now compare this 37 with 48. Okay, there is a no change because 48 से 37 less है, so there is no swapping. So remains, these two numbers remains as it is. Now in next iteration, 40, compare 48 to 57. Again there is no change because there these 48 and 57 are there in proper location. There is no need to swap these two numbers. Now again 57 is compared with 33, so there is a swapping because 57 is greater than 33, so we need to swap these two numbers in next iteration. So we here we write 25, 12, 37, 48, 33 and 57. So in first pass we got the highest element. Okay, now next we perform the second pass. Again second pass, first element is compared with second element. If there is any swapping, perform that swapping. If no need to change the elements, then remain that elements as it is. Then compare first element with second element. Again there is any change or swapping, perform that swapping. If no, remain that numbers as it is. Perform these iterations until the second last element is found. Okay, in second pass we got the second highest number. Now perform the pass 3. In pass 3, again compare first number with second, second with third, third with fourth, and we got the third highest number. Okay, so for these 6 elements we require 5 passes. Okay, pass 1, pass 2, pass 3, pass 4, pass 5, and we in last pass all data, all elements are in sorted orders. Here 12, 25, 33, 37, 48 and 57. Okay, so this is the bubble sort technique. In bubble sort technique, number of iterations are performed. In each iteration, first element is compared with second, second is third, third is fourth, and fourth with fifth, and so on. Okay, so this is the bubble sort technique, and the bubble sort algorithm is, here is the bubble sort algorithm. In this algorithm we pass first is a array and n is a number of elements. Okay, so first step of bubble sort is start. Initially perform the pass 1. In pass 1 there is a initialization is I is equal to 0. If A of I is greater than A of I plus 1, then perform the interchange, means perform the swapping. Okay, I के जगह हमें I plus 1 का एलिमेंट लाना है एंड I plus 1 की जगह हमें I लेना है. Okay, so increment the I plus 1 and perform this cycle until all iterations are performed or all numbers are compared. Okay, so from starting from first pause, perform this step number 4, 5, 6 to number of passes. Then we got the list of elements in sorted order. Here is the C program for bubble sort. Here we write a bubble sort function. In these functions, same ये जो algorithm ने हमने step लिखा है उसी को हमने इस function में convert किया है. Okay, here we write a bubble sort function who takes two parameters, one as a one-dimensional array A and number of element, and which returns nothing, so we write here void. Okay, so here we declare three number of variables I, temp and pass. पास 1 से हम स्टार्ट करेंगे और नंबर ऑफ पासेस हम परफॉर्म करेंगे जो भी जितने भी नंबर ऑफ एलिमेंट्स है लेस देन 1 नंबर ऑफ पासेस परफॉर्म करेंगे. हर एक पास में हमें हर एक एलिमेंट को हर एक दूसरे एलिमेंट के साथ क्या करना है, कंपेयर करना है. अगर फर्स्ट एलिमेंट इज ग्रेटर देन सेकंड एलिमेंट देन परफॉर्म करना है स्वैपिंग. स्वैपिंग में क्या करना है, फर्स्ट एलिमेंट हमें सेकंड की जगह पुट करना है और सेकंड एलिमेंट हमें फर्स्ट की जगह पुट करना है. So this is the technique which is used in bubble sort to sort the elements or to arrange the elements in proper way. Okay, now the next sort is a insertion sort. Insertion sort technique में हम जो भी sorting करते हैं वो sorting जो होता है वो sorted list and unsorted list में होता है. For example, हम यहाँ पे हमने 6 एलिमेंट्स लिए हैं 15, 7, 22, 3, 14, 2. ये हमारा अनसॉर्टेड लिस्ट है. ओके, इन अनसॉर्टेड लिस्ट इन फर्स्ट स्टेप सिलेक्ट 15. ओके, ये जो फर्स्ट नंबर का एलिमेंट है वो हम हर एक अनसॉर्टेड मीन्स जो भी रिमेनिंग एलिमेंट्स है उसके साथ क्या करते हैं, कंपेयर करते हैं. ओके, सिलेक्ट 15 प्लेस इन सॉर्टेड सेट. ओके, सिलेक्ट हमने 15 सिलेक्ट किया है, उसको हम कहाँ पे प्लेस करेंगे, 15 सॉर्टेड. ओके, देन सेकेंड एलिमेंट लेना है. ओके, सेकेंड एलिमेंट है 7 हमें सॉर्टेड लिस्ट में कंपेयर करना है. वो सॉर्टेड लिस्ट में हमें कौन मिल रहा है, खाली 15 मिल रहा है. तो 15 एंड 7 का कंपैरिजन होगा. 7 एंड 15 उनका स्वैपिंग होगा और वो स्वैप करेंगे हम. 7 आगे आएगा, 15 बाद में आएगा. ओके, अगेन हम नेक्स्ट एलिमेंट लेंगे. नेक्स्ट एलिमेंट जो सॉर्टेड लिस्ट में एलिमेंट है उसके साथ कंपेयर होंगे. फर्स्ट 27 के साथ 22 7 के साथ कंपेयर होगा, फिर 15 के साथ कंपेयर होगा और फिर वो अपनी जगह पे जाएगा. ओके, फिर उसके बाद हम एलिमेंट 3 लेंगे, उसको भी हम हर एक के साथ कंपेयर करेंगे और वो अपने प्रॉपर जगह पे जाएगा. सो दिस वे वी कैन सॉर्ट द लिस्ट ऑफ एलिमेंट्स. ओके, when a new element is to be inserted into a sorted list, it is compared with the elements in the sorted list. Means जो भी हम unsorted list में से elements लेंगे उस एलिमेंट को हमें सॉर्टेड लिस्ट में जो भी एलिमेंट है उस हर एक एलिमेंट के साथ उसको कंपेयर करके जो भी एलिमेंट्स है उसको पोजीशन क्या करना है, शिफ्ट करना है और बीच में उसको पुट करना है उसके प्रॉपर जगह पे. सो दिस इज द एग्जाम्पल ऑफ इंसर्शन सॉर्ट. इसको हम क्या बोलते हैं? इंसर्शन सॉर्ट. ओके. एंड दिस इज द प्रोग्राम फॉर इंसर्शन सॉर्ट. इंसर्शन सॉर्ट, हियर वी राइट अनसॉर्टेड सेट के लिए हमने यहाँ पे एक लूप लिखा है. ये जो सेकेंड लूप है फॉर लूप, उसमें हम सॉर्टेड जो लिस्ट है, ओके, उसके लिए हमने ये फॉर लूप लिखा है. इस सॉर्टेड लिस्ट में हमें जो भी अनसॉर्टेड सेट में से जो भी एलिमेंट लेंगे वो हम सॉर्टेड सेट के साथ कंपेयर करेंगे. अगर उसमें कुछ हमें शिफ्टिंग करना है तो वो हम यहाँ पे इस लूप में, इस इफ सेक्शन में हमने वो उसको उस एलिमेंट को शिफ्ट किया है. ओके. So this is the code for insertion sort. Okay. Then remaining sorting techniques we will see on next lecture. Okay. Today we stop here and continue in next lecture. Good day.